Hey guys, so welcome to our channel, and today we'll discuss about the OSI model. Okay, so first of all, we are going to see that why do we need this particular OSI model? Okay, because initially if we talk about, like, let's say in the old times, okay, in the old times, what used to happen, that multiple vendors, okay, like we can consider two examples as an IBM, and we can consider another example as you can take like Dell. Okay, let's take these two vendors who are manufacturing the devices. Okay, so these two vendors, what they used to do, they used to make their own devices, and those particular devices were used in the network. Okay, now for those devices to communicate, there was no standard protocols. Okay, there was no standards defined that how they are going to communicate. Okay, so what happened, that IBM, they created their own protocols, and Dell, they created their own protocols. Okay, now let's say there's a company, okay, who has to install a network. So what they're going to do, they are going to purchase some devices, and if the company, they have purchased the devices from IBM as well as another vendor, let's say Dell. So what the network admins used to do, they used to create the networks with them. But in that scenario, two networks used to create. Okay, there were two networks. Let's say if we take our example, so there used to be two networks, one for the IBM systems and the another for the Dell systems. Okay, now the problem was they were not communicating with each other, and if somehow the network admins, they provided with the communication also, connection also, then the entire network used to become very complex. Okay, the network communication and the network used to become very complex. Okay, so in case there was a problem, the troubleshooting was even more complex. Okay, so in the year 1984, an organization with the name ISO, okay, an organization with the name ISO, International Organization for Standardization, they came up with an idea. Okay, they came up with a motive to standardize the network communication. Okay, so what they did, they came up with the OSI model. That OSI model stands for Open System Interconnect. Okay, now in the OSI model, what they did, they used to explain that how the network communication is going to take place. Okay, how the network communication is going to take place. So what they did, they divided these particular the entire network communication process into 7 layers. Okay, so if we name the layers, so we have the application layer, we have the presentation layer, then we have the session, transport, network, data link, and physical. So these are the layers we have. Okay, so today we'll discuss that how the network communication is happening and what is the task of each and every individual layer. Okay, so with the help of OSI model, what happened? With the help of OSI model, all the vendors, they came up and they use the same model. Okay, so if we discuss about a model, that what actually is the model. So model is nothing but a set of documents only. Okay, and those documents are having the protocols defined. Okay, and for defining the protocols, they are using something called as RFC. Okay, these documents are known as RFCs, that is request for comments, means the documents in which actually the protocols are defined. Okay, so with the OSI model, what happened? Multiple vendors, they came up and they started using the same protocols. Okay, same standard protocols for the communication. And now what happened, that the communication between multi-vendor became easy. Okay, it became possible that, okay, if we have different vendor devices, and then they are able to communicate. Okay, so now one by one we'll go through all these layers. So we have seen, like, we have application layer, presentation, session, transport, network, data link, and physical. Okay, but now you would say something like, okay, why do I have this numbering like this, that okay, then 7 is up and why 1 is down? Because the layer numbering, okay, the numbering in the layers, that starts from the bottom, means start from the physical layer and start the application layer. So here, if we discuss about that, what is the layer 1, then layer 1 would be your physical layer. Okay, what is the layer 2? Layer 2 would be your data link layer. Layer 3 would be your network layer. Okay, in that sequence, we have all the layers from physical to application. Okay, so now we'll see that what is the task of each and every individual layer. Okay, why we use these layers. Okay, so first of all, let's take an example, or let's talk about the application layer, that why are we using this particular application layer. Now consider a scenario that you have to start a communication. Okay, for example, let's say you have to search something in Google. Okay, So if you want to search something in Google, then what would you do? You would actually use a web browser. Now, what is that web browser? That is an application, means how the user is starting the communication or initiating the communication. So we can say that the application layer is the layer that is providing an interface to the user so that the user can initiate the communication. Okay. Now, when I'm saying that, okay, your application layer is basically we are using the application or it is providing an interface to the users. So here I'm not talking about the application itself. Means, let's say if I'm saying that you are using web browser for initiating the communication, so your web browser itself is not an application. Okay, your web browser depends on the application layer protocols. Okay, and if I talk about some application layer protocols, one example you can take like your HTTP protocol. Okay, that is hypertext transfer protocol that is used for the websites, for accessing the websites. Okay, so your applications, they are itself not the application layer, but they depend on the application layer protocols to initiate the communication. Okay, so that is the task of your application layer. Now next we have the presentation layer. Now with the name itself, it suggests that it is going to present the data. Okay, so there are two tasks you can say for the presentation layer. So the first is that it is going to decide the format of the data. Okay, means let's say for example, you can consider you are visiting a particular website, then you are downloading some data from there. Okay, so if you are downloading an image, then the image has its own format. Then if you are downloading a music, then MP3 is the format. So it is going to decide the data of the, it is going to decide the format of the data. Because if you see, we are connected either through wire or with wireless, correct? So your image is not traveling through the wire, correct? It is traveling in the form of bits. Okay, now those bits have to be converted into a particular format, and that format will be decided by your presentation layer. Okay, then other than that, we have some more tasks of your presentation layer, like we can say your presentation layer is responsible for compression. Okay, now what is the compression? If I talk about compression, then see, another task is what? Compression. Now compression is what? Compression is basically nothing but reducing the size of data. Okay, that you would reduce the size of amount of data you are transferring. Why would you do that? And what would be the benefit of the compression here? So the benefit of compression would be your speed and efficiency of the communication. Okay, so the presentation layer is going to compress the data. Okay, so it will take the data from the application and it is going to compress it. So with the compression, what is going to happen? The speed and efficiency of communication is going to increase. Okay, then another task for your presentation layer is translation. Okay, translation. Now, what do you understand with the translation? So we know that, okay, in today's networks, we have multi-vendor devices, okay, and the devices, they are working on different operating systems. Okay, so sometimes there can be two machines that are having different encoding methods. Okay, so your presentation layer is responsible for translation. Okay, for translating one encoding method to another encoding method. Okay, that is another task of your presentation layer. The third task you can say for your presentation layer is again one more task, that is encryption. Okay, so the sender side presentation layer, okay, the sender side presentation layer is responsible for encrypting the data, while the receiving side presentation layer is responsible for decrypting the data. Okay, if there are two machines who are communicating over the encrypted connection, then your presentation layer, sending side presentation layer will encrypt the data, as well as your receiving side presentation layer will decrypt the data. Okay, then next layer we have is your session layer. Okay, now what is a session first of all? So session is the duration between the beginning of a communication and the ending of a communication. So you can take an example like, okay, our session started at this particular point of time. Okay, and the duration from the start till end of the session, that will be known as a session, means that time duration is known as a session. Okay, so your session layer is responsible for maintaining that session. Okay, so it is session layer is going to establish a session, then it is going to maintain the session. Okay, and it is going to maintain the session as long as the communication or the data transfer is going on. And as soon as the data transfer is complete, your session layer is responsible for terminating the connection so that the resources will not be wasted, okay, to avoid the wastage of resources, okay. So that is the task of your session layer. Then if we discuss next, we have your transport layer, okay. So what is this transport layer? Transport, you see that it is responsible for end-to-end communication, okay. Means if we have two devices, then for end-to-end communication, we have your transport layer. And at the transport layer, we have two important protocols. One is TCP and the second is UDP, okay. TCP and UDP, that is transmission control protocol and user datagram protocol, okay. These are the two protocols that are being used at the transport layer. Now the task of your transport layer is one, end-to-end communication. Then what it is going to do, it is going to take up the data from your session layer and it is going to break it into smaller parts, okay. And those smaller parts will be known as segments, okay. So kind of you can say it is also responsible for segmentation of data, okay. So it is going to convert the larger data into smaller chunks that are known as segments. As well as here we use two important protocols, that is TCP and UDP. Also you can say that at your transport layer, your transport layer is also responsible for your flow control, and second thing is your error control, okay. Flow control and error control. Now what is flow control? Flow control is basically controlling the flow of data, okay. So if you take an example, let's say we have one system here, another system here, okay, and these two systems are connected to each other, okay. Then here we have the sender and this side we have the receiver, okay. So if your sender is able to send data at 100 Mbps and receiver is able to receive at only 10 Mbps, okay. So means the speed here, it's not matching. So if your sender starts sending the data at its full speed, that is 100 Mbps, the receiver will not be able to receive the same amount of data. And what will happen? Eventually, the packets will drop, okay. So for this purpose, the receiver is going to communicate, the receiving side transport layer is going to communicate with the sending side transport layer, and they are going to make a decision, okay. The receiving side transport layer is going to tell your sending side transport layer that I'm not able to receive at 100 Mbps, please lower down your speed, slow down the speed, okay. So what your sender is going to do, it is going to reduce the speed of communication, okay. In same way, if the sender is sending at a slow speed and receiver is able to receive at a higher speed, again the receiving side transport layer will tell the sending side transport layer that I'm able to receive at more speed, kindly increase the speed of communication, okay. So means the controlling, or you can say increasing or decreasing the speed of communication, that is known as your flow control. Second thing is what? Error control. So again, your transport layer will check the packets for errors, okay. So if there is an error in the packet, what it is going to do, it is going to drop that packet and then ask for retransmission, okay. So these are mainly the features of TCP. So that we'll discuss in the next video when we are discussing about TCP and UDP, okay. So there will be discussing about all these flow control, error control, okay. Then right now we'll move to the next layer, that is, we can say the layer 3, network layer, okay. Again, an important layer of the OSI model. So the network layer is responsible for, you can say, taking the data from transport layer and then again breaking it into smaller pieces known as packets, okay. So now one is that it has taken packets from your segments from your transport layer and has converted them into the packets. Another task for your network layer is that it is going to facilitate communication between two different networks, okay. So it is going to facilitate communication between two different networks, like you can say it will take packets from one network and provide them in the next or forward them in the second network, okay. That is the task for your network layer, okay. And because of the network layer only, we can say kind of the entire world is right now connected, okay. So we are able to communicate with any of the machines as of now, okay, because of the network layer. So one task is this. Second is One task of network layer, we said that, okay, it is going to take the segments from your transport layer and then convert them into packets. And then second, we said that it is going to provide communication between two different networks. And then also it is going to find the best physical path for data transmission. Okay. Your network layer is responsible if we have a source and a destination. So your network layer is responsible for finding the best physical path for data transmission. Okay. Now, for all this purpose, this network layer uses a special type of hardware that is known as a router. Okay, that is known as a router. So router is the device that is responsible for the forwarding data packets from one network to another network, as well as for finding the best physical path for data transmission. Okay, so if we have two different networks, then your network layer is responsible, okay, for the communication. Then next layer, if we discuss, we have your data link layer. So data link layer you can consider similar to your network layer only. Okay, how? So your data link layer, it's going to take the packets from the network layer and is going to convert them into frames. Okay, that is the one task. Another task is that, again, like I said, network layer is going to provide communication between two different networks. But if you are connected in the same network, in that case, the communication will be provided by your data link layer. And for providing communication between the same network, your data link layer uses, again, a device that is known as a switch. So switch is the device that is responsible for communication in the same network. Okay. Then after, we have the last layer, that is the physical layer. Okay. Now this physical layer is the layer where your packets, or you can say the frames, it will take the frames from the data link layer and is going to convert them into bits. Okay, so here you can say the data will be converted into bit stream. Okay, so in the physical layer, your data will be converted into bit stream. So what is a bit stream? It is a continuous stream of zeros and ones. Continuous stream of zeros and ones. So that is the physical layer that is going to convert the data into bit stream. And it is the name of this layer is physical layer. Why? Because here physical devices are used. Okay, here we use physical devices. Physical devices. Now what are those physical devices? You can consider like your hub, your cables. All these are being used at your physical layer. Okay, so if we take an overall idea that how the communication is happening, okay, so you can say like, okay, if I consider two systems, one is the sender system and the other system is the receiving system. This is the receiver system. Okay, so if the sender wants to send a message, obviously the sender is going to use a application. So first of all, the data will come to the application. Okay, then the application will send the data to the presentation layer, and in this way the data will travel till the physical layer. Now both these hosts, okay, we know that the entire world is connected through the fiber cables, okay, physically connected through the fiber cables, okay, that are lying under the seabed. So here on the sender side, the data will travel from your layer 7 to layer 1. Layer 7 to layer 1. And on the receiver side, now when you are receiving some data, obviously you will receive on the physical wire, okay, and then you will get the output inside the application. So on the receiving side, the data will travel from layer 1 to layer 7. Layer 1 to layer 7. Okay, so on the sending side, the data will travel from layer 7 to 1, and on the receiving side, the data will travel from layer 1 to layer 7. Okay, so in this way, your OSI model is helping us understand the process of communication. Okay, also it is going to help you in the troubleshooting process, that where is the problem, because in your networks, if you are getting a problem, in that case what will happen, that you can check according to the layers that, okay, what kind of problem it is, according to which task it is. Is it a problem with the communication in the same network? Is it a problem with communication in the different network, or what kind of problem it is? So based on the OSI model layers, you can start troubleshooting. Like you can start from physical till application. You can start troubleshooting from layer 1 to layer 7. Okay, so that's all for this video, and I'll see you guys in the next video. If you like the video, do like the video. And if you have any suggestions, do comment. Thank you.